All right, so how does this best line happen is what I want to take a look at. So like I just asked you to draw this on paper, I'm going to try to draw this too. Let's see, so I have my chirps axis, I have my temperature axis there, and I have this line. Let's make the line in green. I'm going to put the line, ooh, let's make a straighter line here. Maybe that's my line. And then my points, let's see, where'd the points go? Boom, 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 boom. All right, let's see if I can graph that roughly. So boom, oops. So here's a point, maybe, here's a point, 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 something like that-ish, close enough. All right. Now, again, in reality is messy, right? Unlike in an algebra class where everything lines up, in reality, they don't line up. So we're getting used to reality here. Why did the computer pick this particular line here? Because there's lots of lines I could draw that roughly go through the pattern the points make. Okay, why this one? So here's how it goes about doing that. Now, what we're doing is, right, we're finding this equation y equals m times x plus b. What's x here? Well, x is one of the values in this table right here. So for this set of data, x is either 54.5 or 59.5 or 63.5, 67.5, 72, 78.5, 83. Those are the different temperatures that were observed. So those are the possible x's. If I plug in one of those x's, am I going to get the same y that was in the data from my equation? The answer is no, I'm not. What's going to happen? Well, let's say we plug in this particular x value right there. When we plug it into the equation, we're going to get this y value over here, right? So we have y from the data and we have y from the equation right here. So I'm going to call this one y. I'm going to call the one from the equation y hat. So put a little hat on your y in the y equals mx plus b there. So my y hat equals mxp plus b was about y hat is about, what was it, 4.25-ish x minus about 158 was my particular y equals mx plus b. And when I plug in one of the x values from the data, it's going to give me a y value that's not exactly the same as the y value from the data. There's going to be a difference between those two. That vertical distance right there is a deviation from average. The line is kind of an average. The points deviate from average, okay? So I could call this distance there a deviation. Another name for it in these graphs is called a residual. So here I have a residual that's positive because it's above the line. Down here, I have a negative residual. Sometimes the residual is very small, like this point in between has a very small positive residual. This, I think, is a very small positive residual. Here I have a negative residual. Here I have a small positive residual, another small positive residual. What the linear regression line calculation attempts to do is minimize the lengths of these residuals overall. Okay, it minimizes those residual distances there. This line has the smallest possible set of residuals, is what happens. Okay, and just like calculating standard deviation, remember I went through how to do that. It's a pain in the butt. We just push a button to do it instead. There is a complicated formula that we could plug in and make the calculation for the slope, for the y-intercept, for the correlation, but let's let the computer do it for us. We just need to know what they means. Know what it means. So for every particular point, the point is going to deviate from the line. The line is an idealized average. Does it always match reality? It's close sometimes, but sometimes it's not so close. But now I have a way to say, hey, what if the temperature was, we didn't have a temperature of, say, 70 degrees exactly in the data, but our line could say, oh, if the temperature was 70, we expect about this many chirps to happen. So let's make that happen next. So let's make some calculations based on our equation and calculate the residuals here. All right. So to do that, I need a couple of extra columns here to work with. So I'm gonna come in between my Y column and where I calculated slope, intercept, correlation, and I'm just gonna insert a couple, I think one's probably enough, column left, sure. All right, so what I wanna calculate here is I wanna calculate the linear regression values. And linear regression is the Y equals MX plus B thing. So I'm gonna calculate the Y equals MX plus B values for each of these. And let's blow this up a touch. All right. So how do we do that? Well, to do a calculation in a spreadsheet, you always got to type equals first. And my M lives over here. So I'm just going to click where M lives. Where's X? X is over here to the right in the same row. Plus B lives over here. That's my Y-intercept. So here's the spreadsheet version of Y equals MX plus B. So let me repeat that. Equals, click on your slope. Times, click on the X value in the row that you're in. Plus, click on your Y-intercept value. Now, what I want to do is repeat this formula for every single row. When I fill this down, what's going to happen is, I'm just going to hit enter for now. The computer's going to then, in the next row, switch from the first X value to the second X value, and then to the third X value, and then to the fourth X value. I want it to do that, right? However, the problem is when I fill it down, it's going to look for the slope in the next line down here, and then down here, and then down here. I got to tell it, no, 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 the slope's always in row 2, right? Watch what happens if I just try and fill it down. I'm going to get a mess of points that's not similar, or mess of Y values. So if I just fill it down as is, I'm going to get a bunch of zeros because it's looking in the wrong place for the slope. So I need to say, no, 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 stay in row 2 for the slope and the intercept. So here's how we do that. So I'm going to go back to my formula here, and I'm going to double click to get inside of it. What I need to tell it where it says the slope is E2, I want to fill this down. It's going to want to change row 2 to row 3. I stick a $ in front of the 2 that says, no, no, don't change the row, please. Okay, so I want it to say equals $2. Can you see that, Grace? Okay, so I'm gonna start completely over. All right, so first line for the next to the chirps data, I'm going to type equals, and then I'm going to click on the slope. And then I'm going to go a times, and I'm going to click on the first X value, right? And then I'm going to do a plus, and I'm going to click on the Y-intercept. Now, I know I need to fill this down, so I need to fix some things. I need to fix the slope by squeezing in between the E and the 2 and slipping in a $ saying the slope is always in row 2. I want to do the same thing for the Y-intercept, slip in between, getting right in front of the row number and stick a $ in there. So what does this say? It says the slope is in a fixed position. That's what the $ says. It says the Y-intercept is in a fixed position, but the X value that gets multiplied by, that's going to vary, is what this formula says. Hit enter, and then go click back on it, grab that bottom corner and fill it down. And it should make the right calculations here. What I should get are numbers that are close to the numbers on the left, but not exactly. So for example, my first one is 74.0466 and then 95.318 and so on down the line. If you have any trouble making that happen, let me know. It's okay. Yeah, it takes a little getting used to here. Stat key's easier, but it doesn't do this. Stat key doesn't make this calculation for us. It doesn't tell us what the model gives us. So if your numbers don't match mine, let me know. We'll straighten it out. Grace needs to sit in the front row. All right, so those are my numbers right there. I don't want to graph them, but what I do want to do is calculate those residual values that I drew pictures of. So I'm going to make another column here. I'm going to call it residual. Okay, so remember, a residual is just a difference between what the data said the Y value should be and what the equation says the Y value should be. Okay, and that difference is always going to be data minus regression line. So type equals for the first residual, click on the data value for chirps minus the linear regression value for chirps. That's what a residual is. Hit enter. Google's offering to fill that one down. That one actually fills down easy. So I'm going to say, yeah, do it for me. I'm done. Those are my residuals. Yeah. Where it should happen. Okay, we can take a look at that later. Somebody emailed me about a homework problem like this they had a hard time with. I'll go over it. We'll do a couple of examples like this. So I just want to look at my graph and see if this kind of matches what I was seeing in the graph. It says the first residual is around 7, the second one's around 2, they're positive. Okay, what does that mean? That means the point is above the line. If the residual is negative, that means the point is below the line. So looking back at my, let's look at the stat key graph here. Yeah, so this first point is above the line. The second point is closer to the line, so it has a smaller positive residual. The next point is below the line. It had a pretty big negative residual, relatively big, and then a slightly smaller negative residual. So that's the pattern I should see in my data. Okay, so we just calculated those vertical distances. Okay, and there's one homework problem where I say, okay, find the equation of the line, and then for this particular point, tell me what the residual was. And you just have to go through these steps we went through here. I have a video with the problem that shows me doing this again with a different set of data. We're going to do it again in a few minutes. Whew. Okay, that was a lot.